Moving on to the Adept level. Finding missing sides and angles. So here's where we're actually going to put the tangent ratio to use. And once you do a few examples, I think it'll be a little bit more clear. So almost any scientific calculator has trigonometric ratios already built in. We've established that. So these three examples here are just an exercise in pressing buttons. So with your calculator, take the tangent of 20, okay, equals. So that decimal that you have in front of you, that is the ratio of what the opposite would be divided by the adjacent. So this is, if I go to 4 decimals, 49.7, ooh, I've got to be careful in my rounding here. This would be 3,640, because that fifth digit was a 7. Tangent of 70, okay, I get 2.7475 approximately, and the tangent of 53 gives me 1.3270. Okay, so just get comfortable with using this feature on your calculator. Question 1. Use the tangent ratio to solve for the missing side. How on earth do we do that? Well, let's look at what we have. I have a right triangle. It is not isosceles. Okay, we can tell just by looking at it, but this is 36 degrees. Okay, we don't need to determine this angle. Why don't we do that just for fun? Okay, remember all three angles have to add up to 180. So 180 minus 90, which is 90, minus 36 gives me 54 degrees. Okay, these angles are not the same, so we know this is not an isosceles triangle. It's actually what we call a scalene. This here, this is the adjacent. Okay, if I'm using this as my original theta, x is therefore the opposite because it's on the opposite side. How can we actually determine the length of x? Well, according to the tangent ratio, we know that the tangent of 36, which is a ratio, it's a number that I can get from my calculator, that is equal to the opposite, which is x, divided by the adjacent, which is given as 8. Okay, well, we actually have an equation now, and x I can now solve for by isolating. And all I have to do is get rid of this division by 8, and I can do that by multiplying. So I'm going to multiply both sides by 8. There we go. So 8 over 8 cancels. That just gives me 1. So that means 8 multiplied by the tangent of 36, that is x. Well, I can just put this into my calculator. So I type 8 times tan of 36 equals, and I'm going to get a decimal, but oh well. I'll go to the nearest hundredth this time. So this x is approximately 5.81. Okay. And that number should seem reasonable. Okay. If this is of length 8, that's 36 degrees, we can tell x has to be slightly less than 8. So if I got a number like 10 or 20, that should indicate that I, well, probably made a mistake somewhere. Right? So x is about 5.81. So I've actually used this angle to help me find an unknown side. Congratulations. Let's try another one. So here I have a right triangle. X is the adjacent, okay, because that's my theta. That's the angle that is given, 63 degrees. Therefore, this 13 is the opposite. So I want to figure out x. So the tangent of 63 degrees, by definition, that is the ratio of the opposite divided by the adjacent. Okay? So again, this is just a number that I can put into my calculator. So I've created something quite similar to what I had over here. The only difference is x, which is what I want to solve for, is in the denominator. So the algebra required is just a little bit different. So in order to get x by itself, I first need to get it out of this denominator. So kind of like what I did with the 8, I'm going to multiply both sides by x. Okay? X is just a number. So x over x, that cancels. That just gives me 1. So now I have x multiplied by the tangent of 63 degrees. That is equal to 13. Okay. Well, if I want x by itself, I need to get rid of this tangent 63. Again, this is just a number. So, because they're being multiplied together, I can undo that by dividing. But I have to divide both sides. Okay. So tan 63 divided by tan 63, that cancels. So again, this is just a number. That's just 1. So if I want x, I simply have to take the number 13 and divide it by the tangent of 63 degrees. So let's put it in our calculator. So 13 divided by tangent of 63, and I get approximately 6.62. Okay. Does that number seem reasonable for the picture? Yes. Okay. This angle is larger than 45, so if this is 13, I would expect x to be significantly less than 13, and sure enough it is. Number 2. Suppose we already know two sides, but we want to determine the angle. So here's a triangle. The angle is just given as theta, so it's unknown, but the opposite and the adjacent are both given. Okay? How can we find this angle? Well, it's almost like we have to work backwards. And there are two methods. One is the guess and check method, which I think is very silly and impractical, but I'll demo it just for kicks, and then I'll show you what I call the smart method. Right. So let's set up what we know. We know that whatever that angle is, so we just leave it as theta for now, the tangent of it must be the ratio of 7.5 divided by 15. Okay? So this is a number I can work out, and that is actually 1/2. I can write that as a nice decimal. Okay? So I need to figure out what angle can I put in my calculator such that if I take the tangent of it, it gives me 0.5. Okay? So let's just look at the picture and let's take a guess. Maybe this is 30 degrees. Okay? Let's check. See how close we get. The tangent of 30, okay, that is about 0.5774. I'd like to do better than that. Okay, maybe it's a bit smaller. Let's say 20. Okay. What's the tangent of 20? That's 0.3640. If I go to 4 decimals. And that's way worse. Okay, I've gone down. So I need to go back up. Let's try 25 degrees. So tangent of 25, that is 0.4663. Okay. Let's try 27 degrees. I'm just trying to get really close to 0.5. So tangent of 27. Oh, that's better. That gives me 0.5. 0.995. But that's still not exactly a half. So I could keep going. I could start adding decimals, and I'd be here all day depending on how accurate I want my answer to be. Okay, so you could guess that maybe this is approximately 27 degrees. Okay, but I'm not satisfied with that. That's not good enough. I want to be able to get this angle precisely and quickly. So for that, we're going to use the SMART method. The SMART method works like this. Since it's like we're trying to work backwards from the examples we did before, we're going to use what is called an inverse. So if the tangent of our mystery angle is 0.5, we can go backwards by writing a similar statement, but it's just a bit different. We say this. We say that the angle, therefore, is the inverse tan, and we symbolize that by putting a little -1 up here. It's like an exponent in terms of how and where it is written, but it is not an exponent. Don't think of this as a power -1 of 0.5. Okay, so it's like this, but backwards. And if you look at your calculator, if you see your tan button, look directly above it. You should see a little tan, a tan with a little -1. So, yay! Those are built into the calculator as well. So you'll have to use the shift or the second button. So I'm going to go shift tan. So now I'm using the little inverse tan. And I'm going to put in 0.5 equals, and look at that. It gives me 26.565 degrees. Okay? Of course it keeps going. But as you can see, well, this is close to 27, but I got this so much faster. It's much more accurate. So please, in the future, don't do guess and check. Okay? We're going to use this inverse operation. So let's define it. We know that the tangent is the opposite divided by the adjacent. Therefore, if I want theta back, I take the inverse tan of the opposite over the adjacent. So the ratio is the same. Okay, we just use a different button depending on whether or not we want the ratio because we have the angle, or we want the angle because we already have the ratio. There we go. A couple more examples. Question 3, solve for angle theta to the nearest tenth. Okay, so here I have a tall and skinny right triangle. I have an unknown angle here. That's what I want to figure out. This, of course, is 90 degrees. Well, look at what we know. All right, this 6, okay, is directly opposite. So 6 is the opposite. This is the hypotenuse, which we don't need for the tangent ratio anyway. This, therefore, is the adjacent. So we have both sides to complete the ratio. So by definition, the tangent of whatever that angle is the ratio of 6 to 19. Okay? Yes, you can work this out as a decimal, but 6 divided by 19 is not a very nice decimal. Okay? And if you start rounding and then working with rounded numbers, your final answer for theta is going to be off. So I'm actually going to leave it as a fraction for now. Okay? So if the tangent of theta is this number here, that means that the angle itself must be the inverse tan. Remember, inverse needs that little -1 of 6 over 19. So I'm just going to put this into my calculator. You can use your fraction button if you want, or you can just use a division statement, 6 divided by 19, but make sure you put in brackets. So I'm going to work that out, take the inverse tan, and you should get theta is approximately, and we want it to the nearest tenth, so therefore this is 17.5 degrees. That seems reasonable for the picture. And though the question doesn't ask for it, now that I know what this angle is, I could determine this third angle simply by taking 180 minus 90 minus 17.5, and that would give me this angle left over. Okay. Next example, another right triangle. There's my theta here that I want to solve for. Okay. Well, look where this 18 is. Okay? It is on the opposite side. Therefore, that is the opposite. This is the hypotenuse, opposite the 90-degree angle, but for tangent, we don't use it. So by default, this 34 must be the adjacent. So I'm going to set up the definition of tangent. So the tangent of theta is the ratio of 18 divided by 34. Okay? And yes, again, you could work this out as a decimal. It's not very nice, okay? Because then I'd have to start rounding it, and I don't want to do that just yet. So I'm going to leave it. So if tangent of theta is this number here, that means theta must be the inverse tangent of whatever this ratio works out to be. Okay, so I'm going to put that in my calculator, take inverse tan, and theta works out to be, and again I want nearest tenth, approximately 27.9 degrees. Okay, so just to summarize, if it's a side that you're looking for and you have the angle, you would use the tangent ratio. However, if you are missing the angle and you know the sides, and the angle is what you want to find, then you use inverse tan.